In this video, we're going to answer some common problems on continuity on an interval. Let's say, for example, 1, we are asked to identify if the function is continuous on -5 to 5. So examining the function here, we have 3x minus 1 over x minus 4. The domain of the given function would be all real numbers except 4. So if we're going to do f of 4, and then we do direct substitution, we have 3 times 4 minus 1 over 4 minus 4. So we have 11 over 0. Because f of 4 is undefined, then we are discontinuous at x is equal to 4. In reference to the given interval, x is equal to 4 is included in the given interval. Therefore, the function is discontinuous at x is equal to 4. Another example, let us identify if the given piecewise function is continuous on the given interval. So we have x plus 1 and x over 4 plus 7. These are both polynomial functions. And polynomial functions are continuous everywhere. But since this is a piecewise function, this function may possibly be discontinuous at 8. So let us try to verify. So let us have f of 8. So we have 8 over 4 plus 7. We're going to use the second function here for f of 8. So this would be 2 plus 7. And therefore, we have 9. So let us try to identify first the limit of the function as x approaches 8 from the right. So we're going to use x plus 1 for the right-hand side limit. So we have 8 plus 1, and therefore this is 9. Let us now get the limit of the function as x approaches 8 from the left. So we're now going to use the function x over 4 plus 7. So by substitution, we have 8 over 4 plus 7, and we have 2 plus 7, and therefore we have 9. Since the right-hand side limit is equal to the left-hand side limit, then the limit of the function as x approaches 8 is equal to 9. And since f of 8 is equal to the limit of the function as x approaches 8, then we can say that the function is continuous at 8. And on the given interval 4 to 10, the function is continuous. For example 3, let us identify the intervals where the given function is continuous. So 2 minus x is a polynomial, same with x squared plus x minus 1. So we can say that the function would be continuous everywhere, except possibly at x is equal to 1. So let us try to verify. Let us first get f of 1, and we're going to use the function x squared plus x minus 1. So we have 1 plus 1 minus 1, and we have 1 for f of 1. Let us now get the limit of the function as x approaches 1. So let's try to get the limit of the function as x approaches 1 from the right. So we're going to use x squared plus x minus 1. By direct substitution, we have 1 squared plus 1 minus 1, and therefore this will be 2 minus 1, and we have 1. For the left-hand side limit, we're now going to use the function 2 minus x. So we have 2 minus 1, and therefore we have 1. Since the left-hand side limit is equal to the right-hand side limit of the given piecewise function as x approaches 1, then the limit is equal to 1. Since f of 1 is equal to the limit of the function as x approaches 1, then the function is continuous at x is equal to 1. Therefore, to answer the question on the intervals, we can say that the function is continuous on the interval negative infinity to infinity. Another example, we would like to identify if the given function is continuous on the given intervals. So we have to answer 4 items. So before that, let us take a look at our function. So as you can see, we're given a piecewise function and 2x over x minus 4 is a rational function. Same with 5x over x minus 3. Let us first try to get f of 4. So we're going to use the function 5x over x minus 3. So we have, by direct substitution, we have 5 times 4 over 4 minus 3. So this would be 20 over 1, or simply 20. Let's now get the limit at x is equal to 4. So first, let us get the left-hand side limit of the function. So that would be 4 from the left. So we're going to use the function 5x over x minus 3. So by direct substitution, this would be the same as f of c, and therefore we have 20. Let us now get the limit of the function as x approaches 4 from the right. So we're going to use 2x over x minus 4. And then upon looking at our function, if we try to substitute 4 to our equation, we would be having undefined. Or to be exact, that would be 8 over 0. And if that is the case, we are dealing with infinite limits. So what we're going to do now is to use values from the right of 4. So let us write 4.001 times 2, 4.001 minus 4. So for the numerator, our expected answer is positive, and for the denominator, same is positive. Therefore, the limit of the function as x approaches 4 from the right is positive infinity. And since the left-hand side limit is not equal to the right-hand side limit, then the limit of the function as x approaches 4 does not exist, and therefore we are discontinuous at x is equal to 4. Now, going back to the given function, the second function, 5x over x minus 3, is discontinuous at x is equal to 3. Because when we substitute 3 to our denominator, for example, let us try to have f of 3 for 5x over x minus 3. So we have 3 minus 3, and therefore f of 3 would be 15 over 0, which would give us undefined. And because of this, we can say that we are also discontinuous at x is equal to 3. Now, going back to the question, let us try to answer. From our solution, we are discontinuous at x is equal to 3 and x is equal to 4. So if those numbers are included in the given interval, then the function is discontinuous. So let us try to answer number 1, 2 to 5. This is discontinuous. I'm going to write D for discontinuous and C for continuous. For number 2, negative infinity to 3. This is continuous. Though we are discontinuous at 3, but we're just referring to all the numbers between negative infinity to 3. So we are not including 3 in the given interval. For 3 to 4, this is also continuous. Though we are discontinuous at x is equal to 3 and x is equal to 4, but we are excluding those numbers in the given interval. Therefore, the function is continuous on this interval. And for 5 to infinity, this is also continuous because x is equal to 3 and x is equal to 4 are not included in the given interval.